Okay, so now we are starting the session. Welcome back to the problem solving session for week 10 for the course Traffic Engineering. My name is Tanu Singh. I am a PMRF scholar at Department of Civil Engineering at IIT Kanpur. So in today's session, first I will summarize all the lectures of week 10. Then we will discuss some of the practice questions that will help you solve week 10 assignment questions. And then we'll also solve all your doubts. So now let's start with the session. So let's start with summarizing the lectures. We'll start by summarizing week 10 lectures. So today we will be studying about how different transportation scenarios have changed, what are the different management procedures and measures that are being provided. So traditionally transportation problems were addressed mainly through infrastructure expansion. Engineers mainly focused on building more roads, more lanes, or constructing interchanges based upon what is the future traffic forecast. And operational improvements were usually considered only after the infrastructures were developed. However, today the situation has changed significantly. Rapid urbanization and increasing vehicle ownership, then limited land availability and high cost construction make it difficult to continue this approach where we mainly focus on building more roads or lanes. So we need different way of thinking. For that we need a traffic management. We can no longer build new infrastructure to solve congestion problems. So and at the same time user expectations have increased. Traveler now expect more reliable travel time and real-time information, that they are less tolerant with the delays. And coming to the type of congestions are of two types: recurring like daily peak hour congestions, and non-recurring caused by accidents or weathers. Therefore, the focus has been shifted towards optimizing the existing infrastructure and improving the overall efficiency instead of building new infrastructure to solve congestion related issues. Now comes to traffic management. Traffic management involves applying management techniques rather than constructing techniques. So the main aim is to improve traffic flow, enhance road safety and protect the environment. The key idea is to make the best use of what we already have. These measures are generally low cost, quick to implement and provide high impact compared to traditional infrastructure projects. Now coming to the benefits and scopes. Traffic management offers several benefits. It helps in smoother traffic flow, reduces congestion and delays, and improves public transport performance. It also enhances the safety for all users, including pedestrians and cyclists, and provides real-time information to the travelers. These measures are applicable not only in the urban areas but also in suburban or peri-urban areas, or you can say to rural areas, especially during incidents or any special events. So now coming to strategies and limitation of traffic management. Access management controls and where these are some of the major strategies of the traffic management. First is the access management. that controls entry and exit points on roads. Demand management focuses on reducing private vehicle use. Transit priority improves the efficiency of the public transport. Smart system uses sensors AI for the real time traffic control. However, these have some limitations. These measures may sometimes increase traffic demand, require technical expertise and proper enforcement, and they also needs continuous monitoring. Also, conflicts of interest may arise among different group of users. So while traffic management is very effectively, it must be carefully planned and continuously managed. So here we have seen there are the four major strategies. So we will first begin with the access management. This access management, so simply putting, the way we control access to road, intersection, driveways, or even parking areas. So the goal is to let people reach their destination, like homes or businesses or schools, university, whatever their destination is, and also provide safety and efficiency. So it is a balancing act. We need to provide access, but also at the same time we need to maintain the mobility, especially on the major roads. And we don't just think about today. Access management also considers the future development, so the road network grows in a planned, safe and efficient way. So now coming to the importance and benefits of the access management. So well, properly managed access can firstly improve mobility, which means shorter travel time and more reliable trips, enhance safety by reducing the number and severity of the crashes, lowers the environmental impact like emissions, fuel consumption by reducing the congestion, support multiple modes of transport, not just car but also pedestrian, cyclist and public transport. And finally, it ensures that the roads help rather than hinder the growth of business and residential areas. Now coming to some of the key principles of the access management. So first is functional classification. Every road has some main purpose. Freeways are for high speeds, which has mainly focused on the mobility, whereas local roads are for the access to the property. So mixing these functions can create conflicts. So this is the first principle, that is functional classification. Next is we limit direct access to the major roads. So for example, if every house had its driveway connecting straight to the freeway, that will create a chaos. So instead we connect properties to the local roads, which then join higher roads at controlled points. So this is second key principle. Then third is the intersection hierarchy. Roads should connect gradually, that is from local roads to collector, then arterial and finally to the freeway. We just don't jump layers because sudden change increase the conflict and reduce the safety. So these are some of the key principles. Now coming to more principles of the access management. So so the next is signal spacing and coordination. So too many closed space signals slow traffic, increases the delays and worsen the emission. So coordinated signals allow both smooth flow, especially on the arterials where mobility is the key. Next, we protect the functional area of intersection. This area where the driver make decision to turn, merge or stop or accelerate should remain free of driveways or entrance. Crowding it leads to confusion and crashes. Finally, we have minimizing the conflict points. Fewer driveways spaced further apart allows smooth merging and safer traffic. For example, instead of right turns directly at the main intersection, we can use indirect maneuvers through medians to reduce the conflict. We can provide a turning island to uh, separate the turning movement and the straight from each other. That will reduce the chance of conflict. Some more key principles are separate conflict areas. So maintain a proper corner clearance between intersection and driveways. This prevents recurring queues from spilling into intersection and creating a collision. Then removing turning lanes from through lanes. Vehicles slowing to turn in the main traffic flow reduces the capacity and increases the crash risk. Therefore, using different lanes keeps the main lane free, which will therefore avoid uh, the chances of the risk or reducing the capacity of the main road. Then we have a use of medians. So medians can be used to control the right turn movements. Non-traversable medians allow right in or right out access at limited points, which drastically reduces conflicts and improves the safety. Then coming to the supporting street systems. So supporting street system provide alternative routes via local or collector roads. So this reduces the the main focus on the major roads or relieves the congestion on the major road. They ensures local traffic can circulate without always entering to arterial or freeway. So the supporting so instead of going directly or going on the freeway, vehicles can use the supporting street system that are local and collector routes to go from one place to another, so that it could not create congestion on the major highway roads. Then complete street concept. So complete streets are designed for all users like drivers, cyclists, pedestrian and public transport. So the idea is safety and mobility for everyone, not just the cars. So a good example includes a bike lane, then a pedestrian walkways, bus lane and clear crossing. So these are the this is the complete street concept. So these are all the key principle of access management. So we can say that access management is not just about the vehicles, it's about creating a holistic, safe, efficient road network for everyone. So in summary, we can say a controlled access, functional hierarchy, then conflict minimization and complete streets are the main keys to build roads that are safe, efficient and sustainable. So this was all about the access management. Now coming to the next, that was traffic demand management or transportation demand management. So the main goal of TDM is simple. It is to reduce the congestion, improve the more number of vehicle trips, reduce the number of vehicle trips and make our transportation system more efficient. There are four major strategies that are used in transportation demand management. So first is using transit van pooling and carpooling. The second is employer based TDM strategies. Then third is congestion pricing and finally the parking management. So now we will see one by one all of the four strategies of transportation demand management. So the coming to the transit van pooling car and carpooling. So the main goal here is to replace SOV stands for the single occupant vehicle. So we replace the single occupant vehicle trips with higher occupancy modes. So some strategies include the supply of bus, trains, light rails, and designing compact, high density communities to support these transit use. We also use initiatives like priority parking or awards for carpoolers and provide informations that are real time. We provide information about real time public transport arrival and departure. There are also some we do the promotional campaigns to make these modes more attractive so that people can use more of them and shift from single occupant to higher occupant modes. So additionally, park and ride facilities and HOV lanes help computers easily access these shared modes, and supporting car sharing programs is another effective measure. So overall, these strategies reduces congestion, vehicle miles traveled, and emissions, benefiting both the commuters and the environment. So this was the first strategy of the traffic demand management. Then it second was based upon the employer. So here on in the employer based stadium strategy, the idea is to reduce peak hour travel and vehicle trips by targeting the workplace. So the first approach of employer based stadiums is financial incentives. So employer can reward employees who avoid single occupant vehicle, for example offering free or discounted parking for those who carpool or use transit subsidies like free or subsidized buses, shuttles, or make non-SOV commuting cost effective. So these are different ways where the employer can uh, can help or can reward employee in order to help them shift from the single occupant vehicles to the sharing one or public transport. The second approach is facility and services. So this includes infrastructure for biking, walking, or secure bike parking, uh, and also providing showers, lockers, and last mile connectivity. So here the employers can also provide van pool or car sharing programs to reduce the need for employees to drive alone. So the employee himself or the organization themselves can provide particular car or van to help the employees of a particular area to shift from the SOVs to the public transport, or instead of using the single occupant, try the sharing programs. Now coming to the few more employer based TDM strategies. So first is flexible scheduling. So this allows employees to reduce their number of commute trips or shift them to off peak hours. Remember, the main objective of employer based TDM was to reduce peak hour travel and vehicle trips via workplace. So here the if we allowed the flexible scheduling, so this will reduce the number of commute trips or shift them to off-peak hours. Telecommuting, where employees work from home 1 or 2 days a week, is a great example. Then compressed work week, where employees can complete the same number of hours in fewer days. Then flexible start or end times are another options to avoid peak hour concessions. Then the next is the user information. So here employer should provide employees with informations on available alternative transportations, coordinators or marketing campaigns, then informational kiosks or websites or the ride matching services where the people going to a particular location can drive together, or have some educational sessions. These all will help employer, or may reward them, or may try to help them to shift us to the public transport. So by combining these four strategies, that were financial incentives, facilities and services, flexible scheduling and user informations, employers can shift from peak hours to off-peak hours, reduce the overall compute trips, and also benefits employees, society and overall environment. Now coming to the third transportation demand strategy, that is congestion pricing. So the main goal here is to discourage driving in congested areas or during peak periods. So here the techniques are including the variable tolls or on lanes or entire roadways, then area-wide charges or ramp-based tolling. So the principle is simple, that the charge higher tolls during peak periods called red periods, and lower tolls during off-peak periods or green periods. So then transit and carpool vehicles are often accepted to encourage their use. So the impact is very significant here. Congestion and emissions are reduced, delays for essential vehicle decreases, and the funds collected can improve public transportation services. So here we are going to understand what it's mean by variable tolling, or how variable tolling is done. So to implement this variable tolling successfully, a few factors are critical. First is sound traffic analysis that is needed to identify when congestion peaks and how tolls should vary. As we mentioned, red and green periods. So when does that red period starts, or when does this green period end, we need to analyze. Second, it's essential to understand user concerns, so the system is accepted by the committee. Third is toll differences must be meaningful. The reduction during the off-peak hours should be attractive, and the increase during peak hours should discourage the single occupant vehicles use without the unfairly penalizing those who have no alternatives. So there may be the probability, or there will be some employees that come from a particular location where there is no public transport, or there are no other employees coming from that location. So we have to be fair in that case, that we don't penalize them who don't have any alternative rather than single occupant vehicle. Then there is pre-launch publicity, then reminders and enforcement, and provisions for the incidents, like if the accident or bad weather is been given, then the provisions or the reminders are being given to the public transport, so that the system works smoothly. Now coming to the fourth one, that is parking management. So the goal here is to reduce the parking demand and encourage the non-single occupant travel. So strategies include using existing parking efficiently, implementing pricing as a deterrent, and discouraging unnecessary car trips to congested areas. If parking is limited or expensive, people are more likely to use transit or carpool or spike. And the impact of the parking management is broad. It reduces the congestion, improves the urban livability, and support the overall TDM strategies. So these are the all four strategies that are being used in traffic demand management. So the previous, so it is traffic demand management, whereas previous one was the access management. So in access management, these were the key principles, and in demand management, demand is basically comes during the peak hours. So therefore, all of the four strategies are mainly revolves around the peak hours, or includes the employer based things, because mostly in the peak hour are the employers who travels. So these are the different strategies that are used in traffic demand management. So here first one was transit and carpool strategies. The key tools were using public transit, van pools, carpools to reduce the vehicle mile travel, congestion and emission. Then it was the employer-based strategies that rely on incentives, facilities and flexible schedules. So it helps to reduce the peak hour trips and shift to the off-peak hours. And then comes the congestion pricing that uses variable tolls or area charges to reduce peak hour travel and raise fund for the transit improvements. Then comes the parking management that uses fees and supply control to discourage single occupant vehicles trips and encourages model shifts. So together, these strategies provide a comprehensive approach to managing travel demand and improving transportation efficiency. Now coming to the bus priority treatments. So these are the strategies to improve bus travel time, their reliability and overall operational efficiency. So there are two main types of the bus priority treatments. First is signal based priority, which includes mainly focuses on adjusting traffic signals to reduce bus delays at intersection. And the second one is the facility based priority, where we allocate space on roads to help buses avoid congestion. So it is important to understand that the signal priority is effective only if the bus actually reaches the stop line at the signal, whereas facility priority treatments helps ensure buses get there efficiently, setting the stage for the signal priority to work well. So that is difference between when the signal priority works and when the facility priority treatment works. So we will go one by one and understand about these priorities treatment. So first is the signal based bus priority. So signal based bus priority aims to reduce delays caused by traffic signals. Its effectiveness depends on buses reaching the stop line, and it can be implemented alone or alongside facility based treatments. So we classify these signal based priorities into four types. First is passive priority, where pre-timed signal adjustments are done for the predictable bus schedules. Then active priority, where real-time signal adjustments triggered when the bus is detected. And third is real-time priority, an advanced network-wide active system that optimizes signal across multiple intersections. And then pre-assumption, where immediate priority or overriding normal signal phases that really used in the urban bus system. So now we will go through all these subtypes of priorities. So first is the passive signal priority techniques, which uses pre-timed adjusted adjustments, making it most effective when bus frequencies are high or dwell time are predictable. So some common techniques includes the cycle length adjustment, optimizing red and green times to reduce the bus delay, then phase splitting, where dividing signal phase to reduce bus waiting at random arrival, then phase length adjustment, where increasing green time for bus approaches while balancing other traffic, then the area-wide timing plans, where coordinating signals across a network for smooth bus progression. Last is the bus bypass metered signals, that allows buses to bypass metered entries to major arterials. So these were different techniques for the passive signal priority. Now coming to the active signal priority techniques. So active priority works in the real time. When a bus is detected approaching a signal, the system can make the immediate adjustment as per the bus approaching time. So this techniques include green extension. So here the green is being extended if a bus is approaching during a green to red transition. Second is a red truncation, where shortening the red phase for other movements to give the bus green sooner. Then is special phase, where dedicated turn phase is been given for buses to maintain consistent travel times. Then phase suppression, that is skipping non-priority phases when a bus requests priority. So here the main purpose is to reduce bus delay at intersection while balancing traffic flow. Now coming to the advanced signal priority techniques. So that includes real time and the pre-assumption. So in real-time priority uses the network-wide bus detection to adjust signal dynamically, optimize both bus travel time and overall passenger delay. Whereas pre-assumption, immediate priority is given to bus overriding is normal signal operations, but it rarely used in urban settings. It is mostly common for emergency vehicles. So the benefits we get is minimizing the overall and passenger delay, and integrates the multiple intersection for smooth bus progression. Since the advanced signal based priority is mainly is for the uh, network wide bus detection, therefore its benefits only when we integrate multiple intersections. Now coming to, these were all the signal based priorities. Now the facility based bus priorities. So this mainly focuses on helping buses to avoid and congestion and queuing delays, and help buses reach signal efficiently. So the main types includes the busways, where grade separated exclusive corridors are being given mostly on the highways. Then exclusive bus lanes, where urban lanes dedicated to bus are being given to reduce the congestion as compared to the mixed traffic. Then shared bus lanes, where that is being used by buses and high occupancy vehicles, that is less ideal with bicycles. Then queue jump lanes, that allows buses to bypass vehicle queues at intersection. So these are the facility based bus priorities. Then these treatments can be used alone or combined with the signal based priorities for maximum benefit. Now we will see some of these types of the facility based bus priority in more detail. So first is the exclusive bus lanes. So exclusive bus lanes are being designed in multiple ways. First is current or width flow, where a bus moves in the same direction as traffic, usually at the curb side lane. Then contra flow, where bus moves opposite to general traffic on a one-way street that requires clear signage and barriers. Then reversible, where lane direction changes based on peak demand, like morning in one direction and evening in the other direction. Then intermediate, where lane alternates between bus only and general traffic, that relies on sensors and enforcement to communicate its status. So, so in the first one, the for example, this is for the general or mixed traffic, and this is the exclusive bus lane. So, in the concrete bus in the bus lane also moves in the same direction as the traffic lane. Whereas in the contra flow, if this is the lane for the general traffic or mixed traffic, then this is the bus lane which will move in the opposite direction. But since it is moving in opposite direction, therefore we need some type of barriers to separate these two. So we need
Ma'am,
a
one small doubt.
hello.
Yes, ma'am, a small doubt, ma'am.
Yes.
Whether this kind of exclusive bus lanes, these kind of lanes are applicable for Indian traffic also, or you are talking in general?
Yes, yeah, it is present in Surat. They have designed, it's a city in India where in instead of the that middle lane that we
Okay.
assume as median is being given as exclusive bus lanes. So here we have two opposite lanes, whereas the median middle portion is being exclusively given to the bus lane and is running pretty well.
Okay. Thank you. Thank you.
Okay, so these were all about the exclusive bus lanes. Now coming to the queue jump lanes and bus advance areas. So queue jump lanes allow bus to bypass congestion at signals. The key points are the segment is restricted for bus upstreams of the signal. Then the second is the other vehicle joins the normal queue while buses move ahead. Some intersection includes bus advance area, allowing bus to safely wait in front of the green signals. So this is cost-effective way to improve bus travel time without building new infrastructure, and it works best when combined with the signal priority system. So the main summary and key takeaways from the bus priority treatments are first there are two types. First is signal based, that have subtypes that are passive, active, real time pre-assumption, and then we have facility based where busways, exclusive bus lanes, shared lanes, or queue jump lanes are there. The benefits we get as the faster and more reliable bus service, reduced passenger delay, and improved travel times, encourage of using more public transport that will result in less congestion, and optimal result achieved when signal based is being used combinedly with the facility based priority systems. So these were all the bus priority treatments. Now coming to the emerging traffic management measures. So the emerging traffic management measures are mainly aimed at improving the traffic flow, safety, and operational efficiency using the real-time data. So these measures mainly fall into three main categories. One is active traffic management system, then active demand management system, and active parking management system. So active traffic management system Mainly, it includes dynamic control of recurrent and non-recurrent congestions, whereas in demand management, adjust demand on the network in the real time, and in the parking management, real-time parking control and allocation has been done. So the key feature is the word active. This means that decisions are not static or fixed, where rather they are based upon the real-time monitoring and predictive data. So the benefits are significant. We can increase roadway throughput, improve the safety, reduce noises and emission, and make trips more reliable. So essentially, we are leveraging technology to make our existing transportation system more smarter and more responsive. So we will go one by one with all the three management measures, starting with the active traffic management. So active traffic management, or ATM, mainly focuses on dynamically managing congestion, whether it is recurrent, that is daily congestion, or unexpected incidents, that is non-recurrent congestion. So one important strategy is adaptive ramp metering. So here traffic signals on freeways, on ramps are adjusted in real time to control the flow of vehicles entering the main road. This prevents breakdowns in traffic flow, and the sensor detects the cues on the ramp and adjusts the signal timing automatically. Then comes the adaptive traffic signal control, where unlike traditional signals, these continuously monitor traffic on arterial roads, including the queue lengths. They dynamically adjust phase lengths, cycle times, and offsets to minimize delays, stops, and congestion. Then finally, a dynamic junction control that mainly focuses on the merge points and mainline intersections. So these are mainly based upon the real time and it predicts the volume. Then lane usage has been adjusted, and sometimes shoulder lanes are used temporarily, or lane closures are scheduled to reduce conflicts and improve flow. So these are some of the active traffic management strategies. There are some additional strategies that comes under the active traffic management, that is dynamic lane reversal. So in this so it allows lanes to change direction according to demand. So for example, during morning peak hour lanes might be reversed to favor inbound traffic to a city, and in the evening the flow may be reversed. So there may be some dynamic lanes that changes depending upon in which direction peak demand are flowing. Then comes the dynamic speed limits. So this is the another tool where the speeds are adjusted based upon the traffic, weather, and road conditions. This improves safety, mobility, and can even reduce the emissions. So this will overall improve the environmental performance. Then comes the part-time shoulder use. Then it is an example of the adaptive traffic management, where normal shoulders are for emergencies, but during peak congestions or incidents they can temporarily serve as the travel lanes. Sometimes this lane might be limited to just bus or high priority vehicles. Then is the queue warning system that alerts the driver to the upcoming congestion based upon their real-time data, and this reduces the rear end collisions, especially on curves, steep grades, tunnels, or low visibility areas, as the drivers already gets an alert of the congestion. So these were all some of the traffic active traffic management strategies. Now coming to the active demand management strategy. So in the demand management, or ADM, It mainly focuses on influencing travel demand and its behavior. So the goal is to reduce congestion and optimize travel pattern and encourage shift to alternative modes of transport. So one of the ADM strategy is the dynamic fare reduction. Here, transit fares are reduced when congestion is increased. So, this will encourage the traveler to switch from the single occupant vehicles to a transit, and fare chances are communicated through the apps or websites to ensure travelers are informed uh, better way. So sometimes when the congestion are more, there may there then you're using the news channel or apps, the occupants or the travelers are informed that the fares for transit are reduced so that they can use or they are encouraged to use the public transport instead of using their own private vehicles. Then another strategy is dynamic high occupancy vehicle or managed lanes. So normally HOV lanes are fixed, but in this approach, lane eligibility changes based upon the current traffic conditions. So a lane might operate as a general lane to HOV lane, this or transit only lane. So that depends upon what that maybe on the on the off peak times these may be switch it to the general lanes, but during the high demand they are treated as the transit only lanes. So the flexibility of optimizing the lane usage may reduce the congestion. Now, some more of the demand management strategies are dynamic pricing. So, it is mainly applied into the tolls. So, unlike fixed variable pricing, here toll rates are adjusted in real time. So, in the variable pricing, we do at red periods and green periods depending upon of peak time and peak time, whereas in the dynamic pricing we adjust the rates in real time based upon the traffic congestion levels. So this helps maintain traffic within optimal capacity limits rather than simply generating revenue. Then comes the dynamic ride sharings that uses technology like smartphone or social networks for short notice or one-time shared rides. So this reduces the number of vehicles on congested roads and encourages real-time carpooling. So it's dynamic because it responds directly to the current traffic situations and user demands rather than being fixed daily arrangement. Now coming to the active parking management. So these were all the active demand management strategies. Now the parking management strategies. These mainly focuses or dynamically managing the parking to optimize its utilization and reduce the congestion. So key strategy here includes the dynamic parking reservation where the travelers can reserve parking spaces in advance using the real time information. And then is dynamic wayfinding where drivers are guided to available space in real time, reducing the time spent in searching for parking their vehicle. Then dynamic pricing where parking fees are adjusted based upon its demand and availability to balance both supply and demand. So the overall goal is to influence the travel decision, including the trip timing, mode choice, parking locations, thereby reducing congestion and improving efficiency. So if there is more price to park their vehicle during the peak period or during congestion, therefore the travelers may avoid traveling through their own vehicles and using the public transport. So these are different ways just to influence the travel decisions of the travelers to reduce the congestion and improve efficiency. So the key takeaways from the emerging traffic managements are that these are mainly manage all the traffic demand and parking management mainly rely on the real time and predictive data, and the dynamic nature of these measures allows the operations to adjust based on the current and anticipated conditions, and the benefits are the better traffic flow, reduced congestion and emissions, and improved safety and optimized parking usage. So, all of these are the been done using the AI and predictive algorithm supports, which allow transportation agencies to make more informed and real-time decisions. And in since these strategies helps us to make the best possible use of the existing infrastructure without having built new roads immediately. So these were was all the summary of week 10 lectures. Please let me know if there's any doubt or else we will start with practice questions. Okay, so since there are no doubts, we can start with practice questions. So the first question is, which type of congestion occurs regularly during peak hours? A is non-reoccurring, B is seasonal, C is reoccurring, and D is random congestion. Okay, so now we'll discuss the solution. So the correct answer of which type of congestion occurs during peak hour is reoccurring congestion. So because the recurring congestion happens at predictable and occurs at the same time each day, such as morning or evening peak hours when people travel to or from work or college. So it is mainly caused by a regular patterns of high traffic demand. So that is the recurring congestion. Now coming to the next question, that is non-recurring congestion is mainly caused by A. Daily office hours, B. Poor road design, C. Accidents and weather conditions, and D. Population growth. So it is mainly caused by which of the following? Correct. It is. Okay, so now let's discuss the. Okay, so the answer for this question is C, that is accident or weather. Since non-reoccurring congestion is happens unexpected and is irregular, so it is can be mainly caused you by traffic accidents, bad weather, or road works or vehicle breakdowns. So out of these four, accidents and weather conditions can be the reasons of for the non-recurring congestions. Now coming to the next question, that is, which of the following is a benefit of traffic management? A. Increased congestion. B. Reduced safety. C. Reliable travel time. And D. Higher emission. Okay, so the correct answer is reliable travel demand. So the traffic management is a system that works to reduce delay or improve traffic flow and make travel times more reliable or more predictable and improve more safety. Whereas these three are on the negative outcomes, not the benefits of traffic management. Therefore, out of these, reliable travel times is the benefit of traffic management. Then the next question is, what is the purpose of supporting street system? A. To increase vehicle speed on major roads. B. To provide alternative routes and relieve congestion on major roads. C. To remove intersections completely. And D. To limit pedestrian access. So, what is the main purpose of supporting street systems? Okay, so let's discuss the solution. So these supporting street system. So these supporting street systems are mainly designed to distribute traffic across different roads and reduce so that it reduces the pressure on the major arterial roads and also provide the alternative routes for local traffic. So out of all these four, the main it matches with the statement on option B, that is to support alternative routes and relieve congestion on the major roads. Now, the next question is why is spacing signals properly important in access management? A. It allows for uncontrolled turns. B. It improves traffic flow and reduces delay. C. It increases conflict points. D. It makes intersection more complex. Okay, so now let's discuss the solutions. So the proper spacing of signals is done to ensure that there is smooth movement of vehicles, there is reduced stop and go traffic, and there is better coordination between the signals. So if signals are too close, then vehicles stop frequently, causing delays and congestions. Therefore, out of these four options, the the main reason to provide signal spacing is to improve traffic flow and reduce the delays that has been caused because of frequent stop and go traffic. Coming to the next question, that is what is the main conflict in mixing mobility and access on a road? A. Higher vehicle speed reduces safety. B. More access points slow down traffic and increases crash. C. Traffic signals become unnecessary. D. Pedestrian traffic decreases. Okay, so here it's been asked using why we don't mix mobility and access together. So mobility mainly focuses on traffic moving more quickly or more fast moving traffic, whereas access means the that allows uh, the roads mainly that mainly focuses on the entry and exit of the traffic on the roads. So if we mix both the things together, why there is a conflict? Because when both are combined means more access points means more turning vehicles. Therefore, this slows traffic and increases more conflict points. That is leads to high risk of crash. Therefore, the correct statement is B, because if we increase more number of access point means more exit, we will reduce the mobility, and therefore the traffic will move slow, and that will result in the more number of crashes also, more conflict points, more risk of crash. Now coming to the next question is, which of the following is an example of incentive for carpooling? A. Free home delivery. B. Priority parking and awards. C. Tax on bicycles. D. Toll free express lanes for single occupant vehicles. Okay, so now let's discuss the answer. So the carpooling incentives are mainly designed to encourage people to share rides. So the common incentive types includes that we have priority or reserved parking for carpool vehicles, or we gives rewards or recognition programs for employees who are using the carpoolings. So the correct uh, option, that is example incentive of carpooling, is priority parking and awards for the people who are using the carpool. Now coming to the next question, that which of the following is a financial incentive under employer based TDM strategy? First is secure bike parking. B is free or discounted parking for non SOV commuters. C is flexible start and end times. D is informational kiosks. Okay, so now let's discuss the answer. So the financial incentive that directly affects the money or cost. So offering a free or discounted parking for people who do not drive alone and use public transport or does carpooling is the example of financial incentive or the employer based TDM. So option B is correct because secure bar is the facility, not the financial, is a type of comes under the facility and services of employer based TDM. Then flexible start and end time comes under flexible scheduling. That is also comes under that is also type of service or studies, and information is a type of the awareness program. Therefore the correct is option B, that provides. Coming to the next question, which of the following is considered a facility or service provided by employers to support TDM? A. Telecommuting. B. Compressed work week. C. Bike parking, shower lockers, or van pool programs. And D. Pricing. Cordon pricing. Okay. So the uh, under okay, let's go one by one to the options that, and we have to find which of them comes under facility or services provided by the employers. So A is telecommuting, then compressed work week. So these comes under scheduled flexible scheduling, and this is financial incentives, whereas these comes under physical or operational supports that is provided by the employees such as bike parks, showers, lockers, or van pools that will encourage the employees to choose different alternative public transport or van poolings. Therefore this is comes under the option C, comes under the facility or services based upon the employee based TDM. Now coming to the next question, that is, which of the following statements are correctly describes signal based bus priority? A. It allocates dedicated road space for bus to avoid congestion. B. It adjusts traffic signals to reduce bus delay at intersection. C. It allows buses to bypass vehicle queues without any signal changes. D. It is only applicable on highways with exclusive busways. Okay, so okay, the first statement says it allocates dedicated road space. So this statement is related to facility based, not the signal based priority. Whereas B affects the adjusted traffic signals to reduce bus delay at intersection. That is correct because this is signal based. Then again, option C, it allows buses to bypass vehicle queues without any signal changes. That is also wrong because in the signal based priority works by modifying traffic signal timings when bus is approaching, like increases the green time or reduces the red light. So this is wrong. And D is it is only applicable on highways with exclusive busways. That is also wrong because that is related to facility based priority. So the correct is B, that it adjusts traffic signals to reduce the bus delay. Moving to the next question, which of these is passive signal priority techniques? A, green extension, B, phase length adjustment, C, real time priority, D, preemption. Okay, so in the passive signal priority technique, here passive is not rely on the real time detection of buses, but it uses a preset signal timings. So out of all the three, only the phase length adjustment is already planned in advance. That comes under passive signal priority, whereas these green extension, real time priority of presumption, these all comes under active or real time techniques. Now coming to the next question, what is the main purpose of facility-based bus priority treatments? A, to extend green signals only when buses are detected. B, to allow buses to reach stop lines faster and avoid queuing delays. C, to bypass network-wide vehicle detection system. C, to immediately override all traffic signals in urban areas. Okay, um, so the facility-based bus priority treatments involves the physical road design such as bus lanes or queue jump lanes. So and these allows bus to bypass traffic congestion and reach the intersection quickly. So option B is the correct one, as A, it means to extend green signals only when bus are detected. This is a signal-based bus priority treatments. And B is to allow buses to reach stop lines and avoid queue delays. That is mainly based upon the facility type, because it is reaching the stop lines after that signal happens. So it is mainly based on how they reach using bus lanes or queue jump lanes. Then C is to bypass network-wide network vehicle detection system. That is also not correct. And then to immediately override all traffic signals in urban areas. So B is the main purpose of facility-based bus priority system. Then coming to the next question, which type of bus lane allows a bus to travel opposite to general traffic on one-way street? First is concurrent and or with flow lane, B is contra flow lane, C is reversible lane, and D is intermittent lane. So which type allows bus to travel opposite to general traffic on one-way street? Okay, so the correct answer is contraflow lane. So contraflow lane is a type of bus lane that allows it to travel against the normal traffic direction, mainly on the one-way street, that to improve the route efficiency and reduce the travel time. So contraflow lane is correct answer. Now coming to the next question. What is the queue jump lane? A lane for emergency vehicles. B, a dedicated bus lane that allows bus to bypass queues at intersection. C, a lane shared by buses and bicycles for short distance. D, a highway exclusive bus way with great separation. Which of the following is correct regarding the queue jump lane? Okay, so coming to the question, active traffic management system. So active traffic management system uses real-time traffic data and uses a predictive system to adjust the traffic operation dynamically. So it is not fixed or static. So static traffic signals, that is wrong. Dynamic control based upon real-time and predictive congestion, that is correct. Fully controlling parking availability, that is wrong. That is mainly done by the parking management system. So that is also known. And fixed toll rates, so it is not fixed, it is real time solely. Oh, sorry, so it is wrong. So the correct is option B, dynamic control of traffic based on real time. Now coming to the next question. What is the primary purpose of part-time shoulder use? A. To serve as a permanent traffic lane. B. To allow emergency vehicles only. C. To temporarily use the shoulder as travel lane during congestion or incidents. D. To reduce parking fees. Which is out of these options, which is the main purpose of part-time shoulder use? So let's discuss the answer. So part-time shoulders are mainly used to allow the shoulders uh, to be used as a normal lanes during peak congestion or incidents, and therefore to increase the road capacity temporarily. So it is not a permanent lane that is being used. So correct answer is to temporarily see, that is to temporarily use the shoulder as a travel lane during the congestion or incident. Now coming to the next question. How do queue warning system improve road safety? A. By reducing toll rates. B. By alerting drivers to upcoming slowdowns or congestions to prevent rear end crash. C. By increasing parking space availability. D. By controlling public transit schedules. How does queue warning system improve safety? Yes, so the queue warning system is mainly done to detect slow or stopped traffic ahead and warned the drivers via signs or alerts. So this reduces sudden braking or rear end collisions. So the correct uh, answer is option B, by alerting drivers to upcoming slowdown or congestion to prevent rear end crashes. That's how the queue warning system improves the road safety. Now coming to next question. Which of the following is an example of active demand management? A. Adaptive ramp metering. B. Dynamic fare reduction to encourage transit use. C. Dynamic lane reversal. D. Dynamic speed limits. So the active demand management system mainly focuses on influencing travel behavior or changing travel pattern and encouraging people to use more public transport or carpooling. So using methods such as changing price or incentives or and encouraging the public transit use. So the correct option is option B, that is dynamic fare reduction to encourage transit use. These adaptive ramp metering, dynamic lane reversers, speed limits all are a part of active traffic management, not the demand management. Next question. What does dynamic HOV, yeah, or managed lanes involve? A. Permanently converting lanes to HOV lane. B. Dynamically changing lane eligibility based on traffic conditions. C. Charging tolls at a fixed rate. D. Reserving all lanes for buses only. So the dynamic managed lanes mainly includes the adjustment rules who can use the lanes or tolls, and it's based upon the real time traffic conditions. So the correct is B, dynamically changing lane eligibility based on traffic conditions. If there is off peak hours, that can be used as the for the general traffic, and using peak hours it can be used for the HOV lanes or bus only lanes. So it changes its eligibility depending upon traffic condition. Next question. Which of the following is not a strategy used in active parking management? A. Dynamic parking reservation. B. Dynamic wayfinding. C. Dynamic pricing based on demand. D. Fixed toll rates on highway. So, active parking management system includes dynamic pricing, dynamic wayfinding, that is using the information about the real-time parking, and dynamic parking reservation. Only the fixed toll rates on highways not related to the active parking management system. So, this is the correct answer. So, this was all the practice questions related to week 10 lectures. If you have any doubt, please let me know. So, if there are no further doubts, okay, so now we are ending this session and we will meet again in the next week's problem solving session. Thank you everyone for joining.